and this begins EE544 on Thursday, February 6, 2014. We can begin.
I'm sorry. Yeah. Good afternoon, everybody. I'm sorry about that. Okay. Good afternoon, everybody. Let's continue our discussion from last time. We are going to start looking at modeling of both the noise performance and the nonlinearity. Now, remember what I told you last time? In nonlinearity, it's going to generate two nonlinearity effects. Effects is that of what? Compression and the what? The harmonics and the what? The intermodulation components. Clear? A compression, again, we will specify it in just a second by what is known as the what? The 1 dB compression point. Clear? We'll talk about that in just a second. Clear? And again, as I told you, the nonlinearity, when we talk about the nonlinearity, the effect will be crucial as far as what? The maximum power that can be, that the receiver can receive and still be operating satisfactorily. Clear? The lowest power is determined by what? By the noise, not by the nonlinearity. Clear? The maximum power or the highest power is determined by the nonlinearity. Let's see what we started talking about, and we said that this is the model for the nonlinear amplifier. Nonlinear amplifier. By the way, whether it's an amplifier at the transmitter side or whether it's at what? At the receiver side. But I'm strictly talking about what? At the receiver side, because that's where the problem arises. You can see again that this is a linear region, and after that linear region, the nonlinearity will show up. And by the way, here it looks like it's continuing to increase. At a point, it might what? It might also go down, as I will show in just a second. Clear? The way we model the nonlinearity is to say what? We say that the output V naught is equal to what? A function of the input. This is not a frequency. This is not a frequency. This means what? A function of the input voltage. The output voltage is a function of the input voltage, which is equal to what? C sub 0 plus what? C1 VI plus C2 VI squared plus C3 VI cube, and so on. And again, as I told you, we are going to limit ourselves with the what? Up to the third order nonlinearity. Clear? The third order nonlinearity. Okay. Now, we started, first of all, talking about harmonic distortion. In a harmonic distortion, the input is a what? Is a single frequency rather than what? Multiple frequencies. Now, always remember one more time that this is just a what? It's just an ideal situation. The input actually, if you look at it this way, let me see if you can help me here before I show you this. I want you to see, first of all, with this nonlinearity, the harmonic distortion, have you increased the spread? The spread. It was what? It was omega naught. You go into what? 2 omega naught, 3 omega naught, and so on and so forth. I want you to look at this just briefly so that you understand what I'm talking about. Let's assume this is the what? This is the input. The input carrier. Is it a modulated carrier? That's a modulated carrier. This is not a single what? It's a single tone. By the way, in this case here, actually, we don't have a carrier component. Why? Because if we do have a carrier component, there should be a what? An impulse at what? At omega sub c. Did you get my point on that? Yes? Now, let's assume this one goes into what? Into a square law device. Let's assume this is what? X of t. And this one is what? x square of t. Forget about the other nonlinearity. Just look at square law device. Yes? Okay, what is the output equal to? Y of t equal to what? X of t times what? X of t. You agree? What is the effect on the frequency? Y of omega is equal to what? X of omega convolved with what? X of omega. Yes or no? Okay, probably there's a 1/2 pi factor here. Don't worry about it. What do you get by convolving this with itself? It becomes what? Wider. In other words, let me just give you an example. Suppose I tell you what? Suppose I tell you convolve this with itself. With itself. Let's assume this is B, this is B. Yes? What would you get? You get a triangle. And what is this? 2B. So what is the point that I'm trying to make? Is that when you are going to what? When you are going to go through nonlinearity, your spectrum will what? Will expand. Are you following me or not? In here, we are only assuming that we have a what? A single carrier component so that we can see all of these delta functions. But in reality, you will get something like this. Did you get this or not? Yes or no? Okay. And by the way, the more the nonlinearity is, the more what? So wider it is. Why? Because you are what? Again, you are convolving. Whenever you convolve, the bandwidth will what? Will increase. So if you do have, for example, raised to the power 3, what does it mean? With this one, you are going to convolve this with it again. Are you following or not? It will also increase. Did you get my point? Okay, good. Oh, so now we applied VI cosine omega naught t. Now VI, again, as I told you, is usually what? A very weak signal because it's coming from where? It's going from some distance. Clear? Okay, VI cosine omega naught t. The output of the linearity is this. C naught, C1, VI cosine, whatever, all of these things. What do we see? We see that the omega naught component created to us what? A DC component, omega naught component, 2 omega naught component, 3 omega naught component, 4 omega naught component. Yes or no? Okay, let me see if you can tell me. This, by the way, this component, this one here, this one is coming from what? From the next one. Are you following me or not? Yes or no? From the next one. This one goes on and on and on and on. Clear? Okay. So now, what we have is what? Is that we have a single component. It created what? Multiple components here. Clear? Now, you might say, what is the danger of these? Because they happen to be what? Farther away from each other. But you have to remember that if your goal is to design a multi-standard receiver, which means what? A receiver able to work in a what? Multiple bands. Yes? For example, at the 2.4 gigahertz and the what? 5.5 gigahertz. Both of them are what? Are the bands that are used for the 802.11. Yes? Second harmonic of the 2.4 gigahertz band could be very close to the what? To the 5.5 or the 5 gigahertz band. You understand that or not? So it depends on how wide the band of your receiver is. Clear? Okay, good. Now, so what did we say? We defined a couple of items in here. The first one is called the fractional harmonic, it's called the fractional harmonic distortion. Keep in mind, when you talk about harmonic distortion fractional, it's voltages, ratios of what? Voltages, rather than what? Ratios of the power. HD2 stands for what? The fractional second harmonic distortion is the amplitude of the second harmonic. Where is it here? Show it to me. Where is the second harmonic? It's this one. Yes? Where is the amplitude? It's C2. VI square over what? 2 divided by what? Divided by the amplitude of the fundamental. Now, the amplitude of the fundamental, in reality, it's what? It is this guy. Yes? Yes? But you will also get it from here. You agree with me or not? But we are assuming that if VI is relatively what? Weak, the VI cube will be even what? Will be even weaker. You can ignore it, just for simplicity. Clear? So what do I have? I have 1/2 C2 VI square divide, what happened to the 2 here? Here, sorry, 2 divided by what? CI VI, which is this term. So I ignore this term. Yes? Okay, I cancel this with this, and I end up with what? 1/2 C2 over C1 times what? VI. So what do I say? I say the second harmonic distortion, Second harmonic distortion is proportional to the what? To the fundamental amplitude, the fundamental voltage amplitude. Sorry, the fundamental amplitude at where? At the input. Did you get this or not? Yes or no? Notice, by the way, if you want to measure it in what? In dB, what do you need to multiply by? 20. Very good. 20 log this, because this is a ratio of what? Voltages rather than a ratio of what? Powers. Clear? Okay, good. Now, the, again, SG2 is the proportional to input voltage. Similarly, for the third order, which is what? Where this came from? This came from this guy. Yes? Which is what? 1/4 C3 VI cube. 1/4 C3 VI cube divided by what? CI VI. And what do you notice? You notice that the third the third harmonic distortion is a proportional to what? VI square of the input voltage. Now, is this necessarily higher than this or lower than this? It all depends on what? It also depends on the value of what? VI. If VI is strong, relatively strong, why is it relatively strong? Because maybe the transmitter was close to the what? To the receiver. When I say close, which transmitter? The desired transmitter happens to be close to the what? To the desired receiver. Are you following me or not? That's, by the way, one of the reasons that you use power control such that what? Such that if the transmitter happens to be closer to the receiver, very close to the receiver, you really don't need to send that much what? That much power. Which means what? Remember, the power is proportional to the amplitude square. Which means what? You don't need to send that high, the amplitude. If the amplitude is smaller, that the effect on the harmonics will be a little bit what? Lower. Clear? Clear? Okay, good. Now, the total harmonic distortion, what are we talking about? This is very crucial. I need you to understand it. Now, the harmonic frequencies, are they orthogonal? The harmonic frequencies, which means what? Second harmonic, third harmonic, fourth harmonic, are they orthogonal? What does orthogonal mean? Still waiting. When we say two signals are orthogonal, what does it mean? Still waiting. If you multiply these two and integrate over what? One period, the answer would be what? 0. We say the two signals are what? Orthogonal. Just like when you say two vectors are orthogonal, how do you prove it? You take the what? The dot product is equal to 0, because if they are orthogonal, means what? The angle between them is 90 degrees, and cosine 90 is what? 0. Clear? Okay. Harmonically related frequencies, are they orthogonal? Harmonically related frequencies, are they orthogonal? Yes, they are orthogonal. Are you following me? By the way, that is one of the concepts. What? One of the concepts of what? OFDM. OFDM stands for what? Orthogonal frequency division multiplexing. The carriers or the subcarriers that you are going to use, you need to make them what? Orthogonal. So that when you correlate, they correlate with each other, the effect is what? 0. The data on one does not interfere with the other. Did you get my point? I will show you that later on in the semester. And you will also study it in, I'm not sure if 535, maybe in the second half of the 635, but I'm not sure. But in any case, but I want you to understand when I say the total power is the sum of the power in each component. Do you understand that? Yes or no? Listen to me. If I give you two sources that are correlated, they are not orthogonal, they are correlated, and I ask you to find the total power, what do? I think I showed you this before. Did I show you this before? You need to add the what? The voltages, and then what? Square, and then divide by 2 to get the average. Yes? But if the two components were orthogonal, how would you get the total power? You get the total power by what? Finding the power in the first one, plus the what? Power in the second one. Yes or no? So can you explain this one to me? THD, which is total harmonic distortion, don't worry about the square root first. It's the power and the distortion divided by what? The power and the fundamental. Yes? Remember, all the harmonics are what? Orthogonal. So what is it? HD2 square. Why am I squaring? Because the power. And one more time. What is HD2? It's the ratio of voltages. Yes? Ratio? Yes or no? A ratio of voltages. You need to what? Square it to get the ratio of what? Powers. Ratio of powers. Yes? Why am I taking square root? Why am I taking the square root? Because this is a ratio of what? Voltages. Do you understand that or not? So you take the square root. That is called what? The total harmonic distortion. Clear? Clear? Did you understand why I added the power? I added the power because those harmonically related frequencies or harmonically related components are what? Orthogonal. If you take, in other words, if you, what is this? Let's see if you can help me. Cosine omega naught t, cosine 2 omega naught t dt, and you integrate over one period. Oh, this one should be equal to what? 0. If you don't believe me, do it at home and you will see that it's equal to 0. Did you get my point or not? Okay, good. Now, intermodulation distortion. Now, we will, by the way, look at the relationship between this one and this one in a minute. When you deal with intermodulation distortion, how many inputs are there? Wrong answer. I'd say at least what? At least 2. There could be more than 2. Are you following me on that? Now keep in mind, the intermodulation distortion is what? When we say M, F1 plus or minus what? N, F2 plus or minus what? K, F3, and so on and so forth. Clear? And remember one more time, how do you write the order of the IM? The order of the IM is what? Is the absolute value of what? M plus what? Absolute value of N. Did you get it? So if N, M, M, and N equal to 1, 1, what does it mean? You say that it's a what? Order of the what? Intermodulation is what? It's a second order. Clear? Why did I take absolute value? If I have negative sign, it needs to be what? Positive sign. Clear so far? Okay. So we have this. And it's going to pass through what? Nonlinearity. Clear? Now, this table, I wrote, this you will, I will post it and bring it with you in the midterm. Definitely. Heavy. Midterm heavy on this. So you need to, this I already wrote to you the output. So what did I apply? V1 cosine omega naught t, cosine omega 1 t plus what? V2 cosine omega 2 t. Clear? Clear? These are the what? The outputs, the DC, the fundamental. Notice, by the way, in this special case, we are going to assume that V1 and V2 are what? Equal. Yes or no? Do they need to be equal? By the way, do they need to be coming from the same source? They be coming from different sources. Are you following me on that? But I wrote in here the general case, and in here, in the charts, I will show you what? The special case, which is when V1 equal to what? V2. Clear? This, you have to bring it with you in the midterm. In the midterm, you are not going to do what? Cosine cube and stuff. You are going to look up table. Did you get this or not? I will be posting it. And by the way, I would also like you to check to see if it is wrong. If it is wrong, I need to make corrections to it. Did you get my point or not? Okay, good. Now, we will use this in just a second. Let's see what we have here. So these are the two inputs. Again, the nonlinearity model is this. The square term, this is square term, generate what? Generate, what is it generating? The square term. Square means what? It's the whole thing what? Square root. This will generate what? DC and second harmonic. Yes? DC and second harmonic. You agree? Second harmonic of who? Of omega 2. The cross term will generate what? Which one? Which one? There is no first order. There is no first order. We start from what? Second order. Yes or no? This will generate the second order intermodulation component, which is what? 2C2, V1, V2 cosine omega 1 plus omega 2t minus cosine omega 1 minus omega 2t. Clear? Clear? Oh, now remember always, one of them will be gone. Do you understand that or not? One of these components will be what? Filtered out. But the other one might be what? Might be crucial. Clear? Okay, good. We'll get to that in just a second. Now, let's concentrate on this. In other words, don't worry about the third order intermodulation component. By the way, the cubic order will generate what? The third order. The cubic order will not generate second order intermod. You agree? Concentrate on this one. We will look at the other one shortly. Yes or no? Concentrate on the second order. What is it? I want you to understand the notation very carefully. When you see IM2, is not a power. This is a what? The second order intermodulation distortion. Do you understand the distortion? Which means if I take the log, what do I get? I get it in what? In dB, not dBm. Yes or no? In other words, this is not the second order intermodulation power. This is a ratio. Yes or no? Which is defined as what? The amplitude of the intermod divided by what? The amplitude of the what? Fundamental. Where? When I say the amplitude of fundamental, where? Both of them are what? Outside of the outside. I'm sorry. At the output of what? At the output of the amplifier. Did you get it or not? Okay. Now, where is the, show it to me here. Where is the, still waiting. Where is the second harmonic? So I said second harmonic. Where is the second order intermod? This one. C, I want you to see it here. Where is it? C2, V1, V2. Yes? C1, C2, V1, V2. Yes? You take only one of them. In other words, even though they are both terms, but you take only what? One of them, because you are assuming that the other one is what? It's going to be filtered out. Did you get this or not? Okay. Now, what is the fundamental? What is the fundamental? Now, notice, by the way, in reality, the fundamental has what? Where is the fundamental coming from? Where is the fundamental coming from? This term will give you the fundamental. Yes? Will it give you fundamental? Will it give you fundamental? Yes. These fundamentals from the third is this. But I'm going to ignore it for the time being. Are you following me or not? Ignore it for the time being, just to make things simple. So what is it? C1, V1. So what do I have? C2, V1, C2, V1, V2 divided by what? C1, V1. Yes? And if you assume that the V1 equal to V2 equal to VI, then you are end up with this. Yes or no? Cannot hear you. Did you answer where this equation come from? I don't want you to memorize any equation. All of this will be in your 8 by 11. The hard part will be what? Which one to use? Do you understand that or not? Which one to use based on a certain question? I don't want you to memorize any question. If you memorize a question, by the way, your brain will explode. Do you understand that or not? Yes or no? Okay, good. Now, I want you to tell me where did this come from. Look at this equation, and I want you to do the following. You see the harmonic distortion, second harmonic distortion? It was this. Third order intermodulation is this. Do they look? This and this. Which one is higher? By a factor of what? 2. In dB, where did 6 came from? It's 20 log. Yes or no? It's 20 log, not 10 log. So the what? So the second order intermodulation distortion is 6 dB above what? Above the second harmonic distortion. Yes or no? Which means which one is more damaging? The second harmonic, sorry, the second intermodulation component. Did you understand one more time where the 6 dB came from? It's 20 log. These are voltages ratios, not power ratios. Clear? Okay, good. Now, let's see if you can help me. Huh? What are the issues involved with the IM2? In other words, is this damaging? Is this in second order intermodulation components is damaging? Let's see if you can follow me. IM2 contains both low frequencies, which are what? Omega 1 and what? Sorry, omega 1 minus what? Omega 2. And a high frequency, which is what? Omega 1 plus what? Omega 2. Answer me the following question. Could this one be problematic? This one. It could if your receiver is a what? Wideband receiver. This is what we just talked about a moment ago. Yes or no? So the omega 1 plus omega 2, it could be problematic if your receiver is a what? Wideband receiver, because it's a what? Multi-standard receiver. Clear? Could this one be, so for example, if the receiver bandwidth is from 800 megahertz to 2.4 gigahertz. Yes? Answer me the following question. What is this band? 8 megahertz, 800 megahertz to 2.4 gigahertz. You are using your phone as a what? To make what? cell phones, cell calls in what region? In the 800 megahertz region. Yes or no? But you are also using it to what? For a Wi-Fi. Yes or no? Which means your band needs to what? Needs to cover all the way from 800 megahertz to 0.4 gigahertz. Let's assume there are two undesired frequency components at 800 and 900. Yes? Did they pass through the filter? Through the band select? The band select. Do they pass through the band select? Yes, they do. Generate the second order intermodulation. The difference between them is not problematic. You agree? Why? The difference between them is what? Is 100 megahertz, which is far down the drain. Did you get this or not? But is the sum problematic? The sum is problematic. The sum is what? Is the 1.7 gigahertz. Are you following me or not? 1.7 gigahertz. Clear? So this one could be problematic, the omega 1 plus omega 2. Clear? Okay. Could this one be the problematic one rather than this one? Let's see if you can help me. What if I'm using the low IF or the what? Zero IF. Zero IF, we said what? It is what? Going directly from the RF to the what? To the baseline. Yes? If these two carriers happens to be what? These are undesirable, but they are within the what? The receiver band. Yes? Within the receiver band. What is this, by the way? That's a desired channel. Yes? Let's assume I'm using zero IF receiver or low IF receiver. Where will this one be converted to? This one will be converted all the way across, around zero or around what? A low IF. Yes or no? These two frequencies are within the band. Yes? There is a what? There is a second order nonlinearity in the chain. Second order nonlinearity in the chain, which means what? There is a square, some term that has a square in it. You are going to get what? The sum, yes? And the what? Difference. Well, the sum causes me a problem. Why? Because the spectrum is going to be converted all the way to what? Zero. But will the difference cause me a problem? The difference will cause me a problem because they are what? Very close to each other. So the difference will be what here? Are you following me or not? Yes or no? Okay. Yes or no? Can you tell me what is this? This one. Where did this come from? Did you see this one here? If you do have a certain square for one term, you are going to square cosine square is what? 1/2 plus, that's the DC component, will also act. Now, if you use low IF, this has no effect because it's not going to be within the low IF. But if you are using zero IF, that will be there. Are you following me on that? Okay, good. Third order intermodulation. Any question on the second order? This third order intermodulation. Okay, now what am I looking at? I'm looking at the cube. Are you following? I'm only looking at the cube. The square will not generate for me third order intermod. You agree? Okay, what is this one is generating? When you do have a cube, what is it generating? It is generating what? It is generating fundamental, yes? Yes or no? But it's also generating what? Third order intermodulation components here. Are you following or not? Now, in the table, where is it? This one. This one, and this one, and this one, and this one, depending on which one it is. Yes? What is this so that you can see it? It's what? 3 over what? 4. You see this 3? 3 over 4 times what? C3, V1, V2 square. V1, V2 square. You will get, by the way, all combinations. Did you get my point or not? In other words, V1 square, V2, V1, V2 square, V1, help me. V1 square, V2, help me. V1, V2 square. One for the pluses and one for the what? Negatives. Did you get it? Okay, good. Now, let's see the effect of the third order intermodulation. Unlike the second order nonlinearity, which could create in-band IM only if the receiver is a what? Is a wideband. Only if the receiver is a wideband. Third order intermodulation can create in-band IM even if the what? Even if the receiver is a what? Is a narrow band. Did you understand what I just said or not? Even if the receiver is a narrow band, there is always a possibility that you will what? That you will generate in band. Now, let's take the situation here. This is the desired channel. Yes? Now, I have these two interferers at omega 1 and what? At omega 2. Yes? They happen to be what? Close to each other. Yes or no? Okay. The third order of these, which is what? 2 omega 2 minus what? Omega 1, or 2 omega 1 minus omega 2. One of them will be here. Yes? Yeah. Yes or no? The other one will be here. Do you agree that the other one will be here? Why? Because omega 2 is greater than what? Omega 1. So when you take 2 omega 2, it means what? You are doubling this, and then you are subtracting this. This one will what? Move within the what? Within the desired channel. Clear? Even though your receiver is a what? It's a narrowband receiver. Even if your receiver is a narrowband receiver, there will always be a problem. There will always possibility that they will what? They will interfere with each other. Clear? Okay. Now, let's look at the IM distortion, IM3. Again, this is in what? Ratios of voltages. Amplitude of the intermod divided by what? The amplitude of the fundamental. Again, ignore any fundamental components that are generated from what? From the nonlinearity. Did you understand what I just? The fundamental component. So what do I have? Let's take an example. Take one of these. Switch what? 3/4 C3. Yes. V1 square, V2 square. If they are equal, it becomes what? VI cube. Yes or no? Divided by what? C1 VI. Yes? So what do I have? C3, 3/4, C3 over C1 times what? VI square. Did you get it? Tell me now, what do you see? What do you see? You see, now I want to compare it. I want you to compare it with this guy. Huh? Sorry. This with this. C3 is this C3. C1 is this C1. VI square is this VI square. This one is what? 1/4. This one is what? 3/4. Yes? What is this? That's 20 log 3. Very good. That's 20 log 3. Did you get my point or not? Okay, which means what? It means that the intermodulation, third order, intermodulation component is roughly what? 10 dB more than the what? More than the what? The third harmonic component, distortion. Clear? High or low? It's relatively high, 10 dB more. Clear? Clear? Okay, good. Now, this is combine them together. In other words, the output of the second and the third order is all here. Okay, this is what? This is the omega 2 minus omega 1. This is omega 1. This is omega 2. This one is 2 omega 1 minus omega 2. In other words, all possibilities here. So which one is damaging depends on what? Depends on the architecture, your architecture. Clear? This one just showed you all of them. Clear so far? Yes or no? Okay. Now, let's see this one. See if you can help me here. Second order intercept point. Now, first of all, I want you to understand one thing here. What am I sketching here? A logarithmic scale. Yes? I want you to see this slope, and I want you to see this slope. Yes? What can you tell me about this slope and this slope? Which one is higher? By how much? 2 times. Are you following me or not? 2 times. Yes or no? Okay. That's why we are talking about what? Second order. What is this? Notice, by the way, this one actually is going what? Look at my finger. This one actually is going this way. Yes? But I extended the what? The linear region. I'm assuming that it's what? Linear all the way. Yes or no? And I do the same thing with the what? With the second order component. Intermodulation. Yes or no? Okay. What am I measuring here? In here. What is it? Power. So when you read from this, in other words, can you tell me what is minus 30? This minus 30 as far as this is concerned. It means at what? When the input power is this, the second order intermodulation power is how much? Minus 30 dBm. Yes? Can you show me in this diagram where is the IM2? Where is the IM2? IM2 is the what? Is the separation between them. Do you, yes or no? Because IM2 is a what? Is a relative measure. Is it fixed or is it changing? See this one? At this input, it's this one. At this input, it is this one. At this input, it is, by the way, this one will go what? Down there. So at this input, it's this one from here to here. Did you get my point or not? Yes or no? Okay. Now, first of all, let's introduce a new parameter, which is the following. When you extend this curve and it intersects with this curve, we are going to get what is known as what? IIP2. IP2. IP2 stands for what? The second order intercept point. The second order intercept point. How do I define it? The second order intercept point is the value of the what? The input power or the what? Output power. If you are looking at the input power, we call it what? IIP instead of what? OIP. OIP is when you are looking at what? When you are referring everything to the what? To the input. Oops, I messed up. Everything to the what? Output. Yes or no? Okay, good. Now, listen to me. When they meet, yes, then from these two curves, you can figure out what? At every input, in other words, if the input power minus 30 dBm, the input is what? Is the fundamental. Yes or no? If it is minus 30 dBm, what is the output power, the fundamental? Minus 10. In this example, what does that tell you about the gain? It's 20 dB. Yes or no? You went, one more time. Is this a fundamental power? Is this a fundamental power? Yeah, both of them are the fundamental power. Clear? So if you are what? If you are at minus 30, yes? What is the fundamental power at the output? Minus 20, which means the gain is how much? 20 dB. Yes or no? Well, I messed up. What did I say? Oh, minus 30 minus 10. I'm sorry, I was looking at the wrong point. This point here. Minus 30 and minus 10. Yes? Okay, so what do I say? I say the gain is what? 20 dB. What is the IM2 in this, at this frequency? At this power. What is the IM2? IM2 is this one. Are you following on that? Which is what? Minus 10 minus 20. Yes or no? Which means what? When you say the IM2 is what? 10 dB, it means what? 10 dB below. Did you get this or not? See, if you subtract this minus 10 minus 20, yes? You get what? You get 10. So we say IM2 is what? 10 dB, but keep in mind this 10 dB means what? Below. Are you following on that? 10 dB below as the fundamental. Clear? No response. Clear? What is at this point? At minus 20. What is at minus 20? At minus 20, the what? The output power, second order, intermodulation power, and the second, and the fundamental power are what? Equal. Yes? Can you tell me at what voltage does this happen? At what voltage of the input? In other words, can you show me this? See, this one is a logarithmic scale. Yes or no? I would like you to be able to tell me why is this one, why is this line is double slope of this guy? Okay, let me rephrase that. Let's assume the question tell you only this input power. In other words, listen to the question. Listen to the question how you say. The input power is what? Input fundamental power is what? Minus 30. Yes? And of course the gain is what? Is it 20? Yes? So you get what? You get the minus 10 at the output. Yes? And he gives you what is the what? What is the intermodulation second order? Intermodulation at the output, which is what? Minus 20, which means that he gives you this point. Yes? Okay. Can you sketch these two lines? You can sketch these two lines. Yes or no? Then, if the question tells you, what if the input is minus 40? Minus 40 dBm. Is it minus 40? Yeah, minus 40 dBm. Yes? Can you do it graphically? Can you do this graphically? In other words, it's minus 40 dBm. What is the fundamental? Minus 20. Yes? Which means what is the IM20? Sorry, IM2. IM2 is 20 dB, whereas the IM2 here has how much? 10 dB. Did you understand what I just said or not? So the IM2 what? Double. Did you get this or not? Yes? If the question tells you this, just extend this and interpolate, interpolate, interpolate. Clear? Cannot hear you. Now, my question is the following. Can you tell me at where is this point? Where is IIP3? What do I do? Before the log, tell me what do I do? I look at the output, yes? Which one? Which power? IM2. Yes or no? These are what? Voltages. Yes or no? What do I need to do? Square them, divide by 2. Don't forget divide by 2. Why am I dividing by 2? These are all sinusoidal. I need to get averages. Yes or no? And I equate them with what? The output, fundamental power. Ignore this, ignore this. Yes or no? No response. Let's do it. I'm not sure, did you get my point here? Let's do it. The output, second order, intermodulation, power. Now, let's assume again, just for simplicity, V1 equal to what? V2 equal to what? VI or V, just V. Clear? Just V, let's not worry about the subscript. V, yes? What is the power at the second order intermodulation? Is what? C2, yes? B square, the whole thing what? Square, divided by what? 4. Sorry, divided by what? 2, I'm sorry. Did you get it? Okay, what is this? This is C2, B to the 4th over what? 2. Yes? Okay, now, what is the output? I messed up. C2 square, I'm sorry, C2 square. Output, fundamental. Power. What is it? Again, ignore this term. Ignore this term. So what is it? C1 V square over what? 2. Yes or no? Which is what? C1 square V square over what? 2. I want you to see this is equation 1, and I want you to see this is equation what? 2. And tell me, what do you notice? What do you notice as far as the what? The fundamental power as compared to the what? The second order intermodulation power. Is it double? Is it double? That's what I meant. Oh, sorry, I said double. I'm sorry. In other words, is this a square of this guy? That's what I meant. Are you following me on that? Yeah? And when you take the log, it becomes what? Twice. That explains why the slope of this guy is what? Double the slope of this guy. Yes? In a minute, when we do the third order, what would you notice? You will notice that this one will be what? Input raised to the power what? 3. I will show you that in just a second. Did you get my point? Okay. Now, next question. If the question tells you, at what input voltage will the what? Will the output intermodulation, at the output second order intermodulation power will be the same as what? The fundamental power. What do? You equate. In other words, C2 square V to the 4 over what? 2 equal to what? C1 square B2 over what? 2, which means what? V equal to C1. Help me. C1 over C2 times what? I messed up? Square root. Did I mess up? I messed up. 1 second. 2 cancel with this 2. You agree? V square. This one is V square. So it's what? C1 square. There is no square root. I'm sorry. There is no square root. Okay. I'm sorry. There is no square root. So it's what? C1 over what? C2. Clear? Clear? Notice, by the way, when you do power calculations, all of these, in reality, it's absolute value of C1 and C2. Do you understand why? Yes or no? Is it possible that C1 and C2 are negative? Is it possible that the amplifier is introducing 180-degree phase shift? Yes or no? Like, for example, if you apply it to an operational amplifier on the what? Are you familiar with op-amp? Yes. Op-amp has a negative input, positive input. Yes or no? If you apply to the negative input, you are going to get what? 180-degree phase shift. Yes? So I need you to understand that when I say C1 over C2, I meant what? Absolute value. Did you get this or not? Because you are going to square them. Yes or no? Okay, good. Did you understand why is it? Did you understand why is this one double this one? Yes or no? Hey, can you explain this one to me? IM2, when do you use this equation? When do you use this equation? Once you get IIP2, then you can figure out what is this, is this power or is it dB? Is this dB? This one, oh sorry, mistake, typo. This one is what? dBm. Question, is this typo or not typo? Is this typo? This is what? dBm. Both of them are what? dBm. But the difference is what? In dB. When do you use this equation? Can you tell me when do you use this equation? IIP2 is going to be what? Fixed. You agree? What is going to change is the what? Is the input power. By the way, when I say P input, at what? That's the fundamental power. Yes or no? From this equation, you could always track what is the what? What is the intermodulation? The second order intermodulation distortion. Did you get this or not? Yes or no? By having the IIP. And how do you find the IIP2? You find the IIP2 when they are what? When they are equal. Clear? By the way, can you give it to me? Can you give me what is the IIP2? You got V equal to what? C1 over what? C2. Yes? What is the, whether you look at it from the input or whether you look at it from what? From the output. Yes? And whether you took the fundamental or whether you take the what? The second order intermod. It doesn't matter. Why? Because they are equal. Yes or no? What do you plug? In a place of V, you plug in what? C1 over what? C2. What was the fundamental power at the input? At the input, the fundamental power was what? V square over what? 2. And instead of V, what do you plug? C1 over C2. Yes or no? Yes or no? You square it, that's the what? That's where, which power is this? Which power is this? Is this one? You follow me or not? However, this is in dB, which means what? You need to take the 10 log. Did you get my point or not? Yes or no? Okay. What is the relationship between IIP2 and OIP2? Where is OIP2? OIP2 is this guy. Yes? What is the relationship between them? Here's the gain. In other words, you say what? OIP2. Is this what units? Units. dBm. This is power. Okay. OIP2. dBm is equal to what? Is equal to OIP2. So I'm sorry. IIP2 in dBm. Plus what? G in what? dB. Are you following? G in dB. Clear? Yes or no? Okay, good. Now, help me. Help me understand why is this. What do you notice, by the way? What is this? It's still fundamental. Yes or no? What is this? That's the third order. I want you to look at this slope, and I want you to look at this slope. Is this one steeper? That's steeper. Why? Let's see. Are you following me? Yes or no? Exam, by the way, heavy on this. Heavy. And I will always ask it as I will call it cookies. What is, not cookies, not cookies. Cookies. Cookies means what? Means I'll give you numbers, but I need you to know which equation to plug it in. Do you understand that or not? And the equations will be in your 8 by 11. Yes or no? But you need to know which equation to plug in. Clear? No response. Okay, good. Now, let's see. What do I do? Help me. Okay, right now, what do I want? II3. How do I define it? IIP3 is the value of the input power that result in the output fundamental power and the output third order intermodulation power are what? The equal. Which means, listen to me, at that point, what is IM3? IM3. 0 dB. Do you understand what I just said? 0 dB. Clear? Help me. What do I do? Third order is this guy. Yes? Again, assume what? Assume that V1 and V2 are what? Are the same. But keep in mind, these are what? Voltages. Yes? No response. Yes or no? So what do I have? Give it to me. 3 over 4, help me, C3 V cube, the whole thing what? Square over what? 2. One more time. Did you understand why did I divide by 2? Yeah, why? I'm talking about average powers. Did you understand that? Oh, these are sinusoidal signal. Clear? Clear? So what do I get? I get 9 over what? 32 C cube, sorry, C3 square V to the 6. Yes or no? Okay. Now, this is what? One second. I made a mistake. This is not IRP3. This is what? This is the output. I'm sorry. This the output. Third order intermodulation power. Did you get this or not? Okay, good. Now, what is the output? Help me. Fundamental power. Clear? Okay. Can I calculate, by the way, these refer to the input? But what does it mean? All of these components, the third order, are generated at the output. They are not present at the input. I'm not sure, did you get my point? Did you get my point or not? These components are generated at where? At the output of the amplifier, not at the input. Clear? Okay. What is it? Give it to me. Where is it? Fundamental. C1 V square over 2, which is equal to what? C1 square V square over 2. Tell me now, what is the relationship between the third order intermodulation power and the fundamental power? This is proportional to the what? To the cube of this guy. Yes or no? And that explains why. That explains why the what? Why this slope is what? 3 times as much as this one. Yes or no? Okay. Now keep in mind one more time. In reality, where is this one headed to? This headed like this headed like this, and I extended what? The linearity. Clear? Okay. Tell me at what voltage does this appear? At what is the input voltage, V, the amplitude, such that you are going to get what? The power of the fundamental at the output of the amplifier, and the what? Third order intermodulation power at the output to be equal. What do? You equate this with this guy. Yes? So what do I have? 9 over what? 32 C3 square B to the 6 equal to what? C1 square over 2 B square. Yes? No response. Yes? So V to the 4, help me. 16. Yes or no? So it's what? 16 over 9. Help me. A C1 square divided by what? C3 square. Did I mess up? Can you tell me what is the V? Square root over 4 over 3 C1 over what? C3. Clear? Clear? Yeah, and again, keep in mind, these are what? Absolute values. The absolute value of C1, absolute value of what? C3. Clear? This equation is the one that you see in this diagram. This one. Did you understand that or not? So this one is, what is this? What is this? This is the voltage at what? At the IRP3. It's what? Square root. Oops, what happened to this? Clear? No response. Clear? There is a typo here. Can you show me what is the typo? This is in dB. This is in dB, the voltage in dB. This one should be 10. Do you agree? Why? Because there is a square root here. This one, why is this one 10? By the way, do you understand why am I adding? It is a product. Yes or no? But this one should be 10. Correct. Clear? Clear? Okay, let's get back to this one. I will get to this in just a second. Let's get back to this one. Okay, so the third order intermodulation component is proportional to the cube of the signal. The slope is, again, is 3. Okay, now let me ask a question. The higher the IIP3, the higher the IIP3. Again, IIP3, what is the relationship one more time? O. And again, this one is in what? This one is what? EPM. The higher it is, the more linear the device, the more linear the device. In other words, linearity is what is pretty good. If IIP is what? Is high. But if IIP is what? Is low, what does it mean? It means that those are what? Those are getting into saturation very quickly. Clear? Okay. Now, in the homework, I will ask you to prove this equation for me, but it's straightforward. It's straightforward. Let me ask you a question. I want you to understand when do I use this equation? When do I use this equation? Is IIP3 constant? IIP3 is constant. But is this one changing? This one is changing. This one allows you to calculate what? IM3. Question. Is this power or is it distortion? That's a distortion, which means what? This one is this separation. Yes or no? And let's take a value so that at least we know how to read it. Assume the input power is what? Minus 20. Yes? What is the IIP3? Minus 10. Yes? So what do I have? 2 times what? What is this? Minus 20. Did you lose me? Minus 20 minus. What is the IIP3? Minus 10. And then the whole thing multiplied by what? 2. Minus 20 minus 10. Minus 20 minus 10 is what? Sorry, minus 20 plus 10. I'm sorry, plus 10 is what? Minus. And the 2, what does that mean? It means, what does it mean? Sorry, it means from here to here is how much? Minus 20. Yes or no? Yes or no? As from here to here is what? Is minus 20.
The time is 0
Clear?
o'clock.
Now, how do you prove this? I will let you prove it at home in your homework. But how do you prove it? Tell me. Explain to me in words. Explain it to me in words. This IIP3, I will be finding it from what? Substituting this V in which equation? In this one or this one? Or it doesn't matter? Doesn't matter. Why? Because they are equal. Are you following me on that? Yes or no? Okay. And you put it in here? Yes or no? And you for the input power also? Yes? This input power at what? The fundamental. This is the input power at what? At the fundamental. Which is what, by the way? What is it? That's V squared over what? 2. Yes or no? And then you take the dB, you will end up with this equation. Straightforward. Clear? Clear? Okay, good. Now, this is again, as I told you, the third order intercept power of an operational amplifier. Sorry, of an amplifier. This is how. By the way, I want you to see something. Is the IIP3 higher than the dB compression? The IIP3, is it higher than the 1 dB compression? Yes, it is. Are you following on that? Yes, it is. The more linear the device is, this one will be what? Will be higher. This one also will be what? Yes or no? Cannot hear you. So keep that in mind. We'll talk about the dynamic range and stuff like that shortly. Clear? Clear? Okay, good. Now, this I already explained it to you. Above is true even if other higher order, odd order nonlinearity exists. IP3 is by definition is an extrapolation. And if we look at small enough signal level, the cubic terms will dominate the odd order nonlinearity. Do you understand what this means? It means that if you take, remember, third order will only come from what? third order intermodulation will only get if the order of the nonlinearity is odd. But this one tells you what? It tells you that if you take more higher, or for example, fifth order, seventh order, its effect, the domination will be what? Dominated by the third order. Clear? Clear? Okay. This is an example to put everything together before we move to another thing. Let's see if you can follow. This is the type of question you will see in the midterm. This is the quickies I was telling you about. Are you following me or not? I tell you the following. An amplifier has the following specification. These are the specs. Small signal power gain of what? 12 dB. What is that? That's the G. GP. G here. The OIP2 is what? 30 dBm. The OIP3 is what? 13 dBm. Measured at where? Measured at the output or reference to the output. What are the IM2 and the IM3 when the input power is what? Minus 10 dBm. It also asks what is the total harmonic distortion at what? At that power. Yes? Let's see if you can help. IIP2, first of all, is why do I need the IIP2? I need the IIP2 because this equation has IIP. Oh, where is the previous one? I don't know where the previous one is, but for the second order, yes? So I get what? IIP2, or IP2 minus this, IIP3, this. Then I plug in the equation, IM2 minus 28. I want you to understand this notation. Maybe we did not talk about it. What is DBC? What is, do you see this DBC? First of all, is this DB? That's DB. Is this power or not power? That's not power. So DBC means what? Minus 28 dB below the fundamental. That fundamental, we refer to it as what? As the carrier. Did you get my point or not? Don't confuse. When you see minus 28 dBc, this is still a what? It's in dB. It's still a distortion. But you are measuring it with respect to who? With respect to the carrier. Clear? Okay. IM3 is this. Then we know the HD2 is this. IM2 minus 6. IM2, IM3 minus 9.5. And then what? The total harmonic distortion is the square root of what? 0.02. Where does this came from? This came from here. By the way, oh, I forgot one thing. When you calculate the total harmonic distortion, remember that equation inside the square root square? These are not in dB. Did you understand what I just said or not? It's not in dB, which means after you calculate them in dB, you need to change them into what? Non-dB before you square and this. And then you can change it back to what? dB. Clear? No response. Clear? Okay, good. What is this? Now, how do we measure the IP3? Let me see. I need to show you one thing. Okay, I don't want to get into this. Oh, this. How do we measure IP3? How do we measure IP3? Notice again, as I told you, later on in the semester, a couple of weeks, I will schedule an extra session where I dedicated only on measurements. Unfortunately, without equipment. Do you follow me? In other words, everything is on a piece of paper, but I will show you the procedure. In other words, in chance you get into a lab, at least you know the what? The procedure, what to do. Do you understand that or not? We don't have equipment here, or at least I don't have equipment. So, okay, I need you to understand how do we measure the IP3. You apply 2 tones of what? Equal amplitudes at the input. Notice, by the way, we need to apply 2 tones. Otherwise, you are not going to get intermodulation. Apply 2 tones at the input of equal, F equal. Choose omega 1, very close to what? Omega 2. The 2 frequencies are what? Close to each other. To be, choose omega 1 and omega 2 to be what? Both of them are what? In the middle of the operating frequency range of the what? Of the amplifier. Which means what? What does that mean, by the way? It means that you need to figure out what is the frequency response of the amplifier. Yes? Frequency response of the amplifier means what? The range of frequencies that will pass through the amplifier mid-band. Mid-band. Choose 2 frequencies in there. Yes? And run the transient analysis. Runs the transient analysis. Clear? And then what? Get FFT. What is FFT stands for? The fast Fourier transform. Are you familiar with the fast Fourier transform? Fast Fourier transform at the output. You will get all of these components. So you apply P1, B2, you will get these components. Do you follow me or not? From this, you can read it from this screen. Clear? Clear? Okay, good. Now, I want you to see this interpolation equation. By the way, I will not prove any one of these. I will ask you to show it. But they are all straightforward. Are you following or not? What does this one take? First of all, by the way, do you notice these slopes? This one is 3 times as this. Yes? Okay. For a given input power, this is the input power, P1. I want you to see this. Pi, P1. What is the difference between Pi, P1? Pi is the input power. P1 is the input power that you measured, that you were working on. Did you understand that or not? This is an arbitrary input power. This is a what? See, we can use P1 and what? PF and PIM3 to estimate what? IP3. Yes? You are losing me here. What is P0? What is P0? This is the output power when the input power, when I say output power means what? Fundamental. When the input power is what? PI. Yes? What is PF? What is PF? PF is also the output power, but when the input power is what? P1. Did you get my point or not? This is an interpolation equation so that you don't have to repeat the experiment at all what? At all frequencies. You generate it at what? Sorry, at all powers. Yes, so I said at all frequencies. You confuse me. At all powers. Yes or no? You take one of them, and then the rest you will do it what? By interpolation. Did you understand what I just said or not? Yes. I want you to see this. What is this PF? Look at this. This is what? P1. Yes? Where is Pn in this diagram? Where is Pn? Pn is any power on what? On this axis. Yes? What is P0? P0 is any power on this axis. Clear? And these are the simple equations, and you can see that from it you can calculate what all of these IP3, IIP3, and so on. Clear? All of these, by the way, I will let's make it a little bit more interesting. Derive all of the above and email it to me for 1 point. Extra credit. Good enough or not good enough? Yes or no? Cannot hear you. Okay, 1 point extra credit. And the deadline, Friday, which means tomorrow. Friday, midnight. By the way, if you tell me you need till Friday midnight to derive these simple equations, you are in big shock. Do you understand that or not? This one should not take more than what? 2 to 3 minutes. But anyway, did you understand it? You email it to me, email, regular email. Yes, but not as a text, as an attachment. Did you understand what I just attachment means? Either you what? Scan it or you process it. Did you get my point? Did you get my point? 1 point extra. In other words, equivalent to 1 poster. What's wrong with that? Yeah, accumulate. Now, this is the equation that I just showed you. This is another way of what? Estimating it from the harmonic measure. Can you explain this one to me? How do we estimate IP3, IIP3 from the harmonic measurement? I am applying a what? A single waveform, in this case, not 2 waveforms. And I'm calculating the what? The harmonics. And from the harmonics, by the way, when you do the harmonics, what are you estimating? The C1 and the what? C3. Yes or no? Cannot hear you. And from this equation, you can estimate what? What is the voltage of the IIP3? The one that I just showed you a moment ago. Yes or no? Okay, what do you apply? You apply a single tone and measure what? C1 and what? C3. C3 is the what? Is the third order harmonic. Yes? C1 is the fundamental, and from it, again, you take the FFT. You can get all of these techniques. But you have to remember one thing. This works only if your what? If your amplifier is wideband. Why? Because otherwise, the third harmonic component might be what? Out of band. Are you following on that? Which means what? The amplifier is going to what? Is going to attenuate it. Did you get this or not? Okay, good. Now, no, this will wait next time. I want to show you another one, which is the following. You don't need to write anything, just follow me. I will be posting this. What we just saw is how to get the IIP3, concentrate on the IIP3. IIP3 of a single device. The question is what? I have a receiver that consists of what? Multiple subsystems. How would I be able to calculate the overall IIP3? Clear? Did you understand what I just mumbled? Yes or no? We will see the same idea when we get next week to the noise analysis. When we calculate the noise figure of each component, we should be able to find what? What is the overall noise figure? Did you get this or not? This is the procedure, by the way, very simple procedure, but I need to explain to you how to calculate the IIP3 of the what? Entire, which means the following. Listen to me. Don't look at the numbers yet. This, we have a what? An example. Filter, amplifier, filter, mixer, amplifier. Are you following me or not? What is the question it's going to give you? It's going to give you the IIP3 of each one of them and ask you to calculate what is the overall what? IIP3. Did you get my point? Exactly similar, we will do it when we get to the noise. The noise, the question will give you the what? The noise figure of each component, and we want to calculate what is the overall noise figure. Clear? Now, before I show you the procedure, I need you to understand what does IIP3 equal to infinity means. The system is what? Linear. Yes or no? System is linear. Clear? Let's see if you can help me. The procedure. Yes? Okay. This procedure, by the way, you will not be able to bring it with you in the midterm. You understand that or not? Because I need to make sure that you know the procedure. Yes or no? Or maybe I will let you, I don't know, depends on the mood. Okay, can we concentrate? Because I'm running a little bit short. Concentrate. Transfer all the IIPs to the what? To the system input. By the way, it also applies to the system what? Output. Whichever one you choose, doesn't matter. Clear? Transfer all the IIPs to the system inputs, but you need to keep track of what? Whether you need to subtract the gains, and you need to add the what? Losses. If the system is an amplifier, you need to what? Subtract the gain. But if the system is an attenuator, you need to what? Add the gain. Do you understand that or not? Yes or no? Okay, good. I will explain that to you in just a second. After you transfer them all to the what? To the input, change all of them from what? dBm to what? Regular power in milliwatt. Did you understand that or not? Change it everything to milliwatt. Yes? The overall IIP3 is the what? You treat the IIP3s as if they were what? Resistances in what? Parallel. Yes or no? So it's what? 1 over this, plus 1 over this, plus 1 over this. The whole thing what? To the minus what? Did you yes or no? Cannot hear you. Keeping in mind all of these IIPs are in what? In milliwatt, not in dBm. Yes or no? After you find the IIP3 overall, convert back to what? To dBm. Did you get it? Let's see. Did you get it? One more time. One more time. Transfer all of them to the what? Input. Keep track of what? The losses and the gains. Are you following me or not? Clear? Okay. You need also to be careful if the question gives you IIP or OIP. Do you understand that or not? Because if it gives you IIP, the gain of that system will not get into the picture. Do you agree? But if the question gives you the OIP, you need to take that gain into the picture to get what? The IIP. Yes or no? And in the midterm, I will give you mixture so that I fool you. Do you understand that or not? You have to remember, I'm a mean guy. Did you get my point? Yes or no? I don't think so. So let me show it to you. Oh, let me finish. So you refer to them everything to the input or to the output, doesn't matter. By the way, if you refer them to the output, you are getting what? The OIP. Clear? Refer to them input, I think is better. But in any case, and then change them to what? Into non. Question? Yeah, okay. Change them into what? Into milliwatt, and treat them as what? As resistances. Don't forget the -1, because this in reality is what? 1 over R equal to what? 1 over R1 plus 1 over R2. So don't forget the -1 here. Yeah. By the way, if you will get -1, you will get a ridiculous answer. You understand? Of course, you will get a ridiculous answer. And then what? Convert back to dBm quickly. Let's see if you can help me. Filter, passive filter, not an active filter, a passive filter, and I'm assuming that it's a what? Linear. Yes or no? It's a passive filter. It's linear. Amplifier, the gain is 12 dB. The IIP3, what does that mean? I am measuring it at this point. Yes? If the question tell you OIP3, it means you are measuring it here. Yes? Okay. Filter, again, IIP3 equal to infinity. Mixer, IIP3 equal to what? 20 dBm. Help me. Amplifier, IIP3 is what? 20 dBm. And the gains of it. Why is this -7 dB? That's a mix. That's a passive mixer. A passive mixer can only provide you with what? Conversion loss, not conversion gain. Yes? What do? You refer to this one to the input is still infinity. Yes? Okay. Tell me here. What did I do? The 10 dBm, I subtract. I add 2, which means what? Minus 2. So it's what? 12 dBm, and change it to what? Milliwatt. Yes or no? Okay. Infinity, of course, will remain infinity. Why? You add something, it's still infinity. Yes or no? Okay. This, help me. Minus 20 dBm. 20 dBm. 23. Yes or no? 11. 13. That's 13 dBm. Did you get it? And change it to milliwatt. And then, finally, 20. Where is it? 22. Where is it measured? Here. No, not 22. Sorry, 20. In other words, question, does the 22 gets into the picture? No. But if this one is OIP3, you need to take it into account. Yes or no? So, 20. Help me. 27. 30. 18. 20 dBm. Yes or no? 100 milliwatt. And then what? 1 over infinity. By the way, the 1 over infinity will not contribute anything. Clear? 1 over infinity, 1 over this, and to the rates of -1, you get what? 9.1 dBm. Answer me the following question. Answer me the following question. The overall IIP3, was influenced by which system? The one that is the least IIP. Did you understand? By the way, when I say the least IIP, it means what? The least linear. Which one of them? This happens to be this amplifier. Did you get this or not? Yes? It cannot be better than what? Than this guy. So what is it? 9.1 dBm. This one is what? Is 10. Why? Because you are treating them in parallel. Yes or no? When we get to the noise figure, I would show you that the overall noise figure is dominated by the noise figure of the what? Of the first block. Are you following me or not? Of the first block. By the way, was the amplifier the first block here? It was not the first block. Are you following me? It was not the first block. But in the noise figure, no matter what, how much you have, the influence will be what? Will be the one that is the first block in the chain of your receiver. And hence, we need to use a what? Some amplifier which introduces little what? Little noise. The low noise amplifier that has a what? That has the smallest noise figure. Clear? But the noise figure of the overall has to be greater than what? The noise figure of just the what? The LNA. Yes or no? It cannot be lower. In other words, the overall cannot be what? Better than what? Better than each component. Just like here. The nonlinearity, the system cannot be more linear than the what? The most linear component of them. Did you get it or not? Hard or easy? Straightforward. This will be in the middle. Are you following me or not? Yeah.
Is it correct to say that the overall IIP3 equal the overall IIP3 plus the gain of the system?
Of the overall then, of course. The question is what? I need to repeat the question. Then students were mad at me last time. They said, students in the class ask questions and you don't repeat it. Shame on me. What is the question? I forgot. Oh, okay. Once you get, the question is what? Once you get IIP3, the overall, how would you get the OIP3 overall? You need to take the IIP3 and what? Add it with the overall gain. Of course, the overall gain is very easy to do, which is what? -2 plus 12 plus 10, 7, 0, 22. The overall is what? 22. So whatever we get in here, you add what? 22 dBm, you get, I'm sorry, 22 dB, you get yourself the what? The OIP3. Clear? Did I run out of time? Oh. Okay, so remember, I'm going to post this and you will bring this one with you in the midterm. I don't want you to memorize anything. Clear? Okay, but are you following me so far? Okay, good.
This concludes EE 544 on Thursday, February 6, 2014.